Now let's look at a program in serial communication in which you have to transmit a sentence at a standard baud rate. Now let's look at the question. The question is, write an assembly language program to transmit the sentence, we are ready serially at a baud rate of 9600 Hz. So since a standard baud rate is specified, mode 1 should be selected for serial communication. And when you select mode 1 for serial communication, you have to configure timer 1 in mode 2, that is the auto reload mode. And also you should load an initial count into the TH1 register, which will give you the specified baud rate. In this case, it is 9600 Hz. So the first few instructions are related to this. The first step in the program is to select mode 1 for serial communication by making SCON equal to 40H. Now let's see how we got that value 40H. Let's look at the SCON register. For mode 1, SM0, SM1 should be equal to 0, 1. SM2 is not used, it is equal to 0. Reception need not be enabled, REN equal to 0. Data size is 8-bit when the standard baud rate is specified. So TB8 and RB8 will be 0. And reception and transmission are not complete, so RI and TI should also be equal to 0. So except for D6, all other bits should be equal to 0. The equivalent hexadecimal value for the binary pattern will be 40H. So that is why we are loading 40H into SCON. Then we have to select mode 2 for timer 1, since that is required in mode 1 serial communication. So mode 2 for timer 1. For that, since we are using timer 1, we should consider the upper nibble of TMOD register. Gate and CT bar are equal to 0. M1, M0 should be 10 for mode 2. So the upper nibble will be 0010. Timer 0 is not used, so all the bits of lower nibble will be 0. The equivalent hexadecimal value will be 20H. That should be copied into TMOD register. Then we should find the initial count to be loaded into TH1 for the given baud rate. For the baud rate of 9600 Hz, the initial count to be loaded into TH1 is FDH, which can be calculated using the formula, or you can just remember that for 9600 Hz, the initial count in TH1 should be FD. Then after all the initial steps are taken, we can start the timer by setting TR1 high. So the instructions will be as shown. Move TMOD comma hash 20H will load 20H into TMOD register, and this will select mode 2 for timer 1. Then the initial count FD should be stored into TH1 for 9600 Hz baud rate. Move TH1 comma hash 0 FDH will do that. Then move SCON comma hash 40H will select mode 1 for serial communication with reception not enabled. Then set bit TR1 will start the timer. Now we have taken care of all the initial steps. Now we are ready to transmit data. So since this is a long sentence, if we follow the pattern that we followed earlier, our program is going to be very lengthy. We have to transmit data byte by byte. So when a long sentence has to be transmitted, if we just copy that byte into the accumulator, then into SBUF, and if we follow that pattern, our program is going to be lengthy. So what we are going to do is that we are going to store the sentence in program memory. The sentence to be transmitted will be stored in program memory along with the program. And we are going to make use of the assembler directive DB for this. Now look at the sentence given in the bottom portion of the code. Here sentence is a label, and at that label we have used the DB directive. After the DB directive, we have given the sentence in double quotes followed by 0. What the DB directive does is that it assigns a byte of storage for the subsequent data, for the data that comes following the DB directive. So when this assembler processes this statement, what it will do is that sentence will be replaced by an exact address, say for example 3000H. A program memory address will take the place of the label sentence, and at that address says 3000H, the ASCII code of small letter w will be stored. At the next memory location, that is 3001, the ASCII code of small letter e will be stored. At the next memory location, the ASCII code of space will be stored, and so on. And the label will be equivalent to an exact memory location or exact program memory address like 3000H, which we can use in our program instead of the exact address. For example, say if we have to access this data, we have to store that value in the data pointer. So you can use the instruction move dptr comma hash sentence instead of move dptr comma hash 3000H. So once more I will tell you what the DB directive does is that it will store this sentence byte by byte at the memory location specified by the label sentence. And we are storing a 0 to indicate the end of the sentence. I hope that much is clear. DB is an assembler directive. It is not an 8051 instruction. It tells the assembler that the data that follows this DB directive should be stored at the memory location specified by this label, starting at this label. And this label will represent a real program memory address like 3000H. Now, after we have taken care of this storage part, we can move on to accessing byte by byte from this data. See, to transmit serially, we have to get byte by byte of data. We cannot transmit the entire sentence as such. So the ASCII code of W, small letter w first should be transmitted first. Then the ASCII code of small letter e should be transmitted. So in that fashion we should continue. And for that we should access these values one by one. And the instruction that can be used to access or read data that is stored along with the program in program memory is move C a at a plus dptr. This is the instruction that will read data from the program memory. C is for code, move C. C is for code. That will read data from the program memory, and the data byte will be copied into the accumulator. From there we can transmit it serially by copying it to the SBUF and so on, that we have seen in previous programs. But if we have to use this instruction to access data, the starting address of the data should be available in either the accumulator or data pointer. Accumulator is 8-bit, so that is not possible. We have to store the starting address in data pointer. It is a 16-bit address, so it has to be stored in the data pointer. So these are the steps that should be taken care of before we begin transmission of byte. We should first store the sentence in program memory using the DB directive, Then we should access bytes from the sentence one by one using the move C A at A plus DPTR instruction. And to use that instruction, the DPTR should contain the starting address, that is the address corresponding to sentence should be available in the data pointer. The sum of A plus DPTR will give the address of the data that will be copied into the accumulator. So the accumulator has to be 0 and the data pointer should contain the address corresponding to the label sentence. So the instructions to do that will be move DPTR hash sentence. Sentence will represent an actual address like 3000H. So what the assembler does when it converts this program into machine code is that instead of sentence, instead of this label, it will replace the actual address 3000H. Suppose this label corresponds to 3000H. When the machine code is generated, DPTR will contain 3000H. But for convenience, we can use the label in our program. Hash is compulsory since this is to be copied as an immediate value. So move DPTR hash sentence will copy the address corresponding to sentence into the data pointer. Now after executing this instruction, the data pointer now contains the starting address of our sequence. It contains the starting address of our sequence. And accumulator should be cleared so that when we use it in the next instruction, A plus DPTR should point to the value we have intended. If accumulator contains some value and the data pointer contains the starting address, then their sum will point to some other value. So the accumulator should be cleared. So clear A will make the content of the accumulator 0 so that A plus DPTR will point to the first location of our data. Then we can use the move C instruction to get the first byte into the accumulator. Move C A at A plus DPTR will copy the first byte of our sequence into the accumulator. That is, the ASCII code of W will be copied into the accumulator. Now we have a byte to be transmitted in our accumulator. So since now we are ready with the data to be transferred serially, we can now call our send subroutine to send it serially, to transmit it serially. So the instruction for that will be A call send. What does this subroutine do? It transmits the content of the accumulator at the specified baud rate through the THD pin. So the subroutine will be like this. We are familiar with this subroutine now. Send is the name of the subroutine. It should be the label of the first instruction of this subroutine. And the instruction is move SBUF, A. The content of the accumulator will be copied to SBUF. And when this instruction is executed, byte in SBUF will be transmitted serially through THD pin bit by bit. And we will wait on TI flag until this transmission is complete. TI is initially 0 and as long as the byte is not completely transferred, it will be 0. So when TI sets, it means that the entire byte has been transmitted. Until then, we will wait. We will wait until the entire byte in SBUF has gone out through the THD pin. So JNB TI L1, L1 is the label of the same instruction. So when TI is equal to 0, we will loop continuously in this instruction. When TI is set, it means the byte has been completely transferred and we will come to the next instruction. And in the next instruction, we will clear TI and we will return to the main program. Nothing is left to do in our subroutine. This subroutine is intended to transfer the byte in the accumulator serially. That is now complete. So we will return to the main program. So we have finished transmitting the first byte of the sentence. Now what should we do? We should get the next byte. For that we should increment the DPTR, increment the data pointer so that we can take the next byte, that is the ASCII code of E, and transfer it. And also we have to check whether the accumulator content is 0, since please note that we have stored as 0. It is shown in pink to indicate the end of our sentence. So when the ACALL send instruction has been executed and we have returned, what does the accumulator contain? It contains the byte that we took from the program memory that was to be transferred. So now when this instruction is executed first, the accumulator contains the ASCII code of W. Then it will contain the ASCII code of E and so on. And when it contains 0, when its content is 0, that means that all the all the letters of the sentence has been transmitted and we have reached this 0. So when the content of the accumulator is 0, it means the entire sentence has been transmitted, and if not, if the accumulator contains some other value, it means the transmission of the sentence is not complete. We have to repeat. So we should increment the data pointer, then we should check if the content of the accumulator is 0. If it is non-zero, we should repeat the steps that transfer data. If it is 0, our transmission is complete. So the instructions for that are increment DPTR so that it points to the next element. JNZ L2, check if the accumulator content is 0. If it is 0, it means the entire sentence has been transmitted. If not, we should transmit the next element, next letter. So at L2, what should we do? At L2, we should clear the accumulator because suppose that we are at a stage where we have transmitted W. So the accumulator now contains the ASCII code of W. That should not be added with the content of the data pointer. That will change the entire location to some other value. When we use or when we execute moves the instruction, the accumulator content should be 0 so that the content of the data pointer will point to the correct data. So we have now incremented the data pointer and it now contains the address of the letter E. And A should be 0 so that the sum of A plus DPTR points to E. So the next step is clear the accumulator. The content of the accumulator should be cleared so that it can be used in the next instruction. So move C A comma at A plus DPTR will now point to the next byte of data or the next letter in the sentence. Now that has been copied into the accumulator. Then we can call the subroutine to send it serially. Again, increment DPTR, check whether the content of the accumulator is 0 and repeat until we reach this 0. When the accumulator content becomes this 0, it means that the entire sentence has been transmitted. Now we need not do anything else. So we will end our program in a never-ending loop L3 sjump L3. And when we write this program, we can write this program, say, let's start at the memory location 0000H. And we can write this program continuously as shown. This will be at 00. The first instruction will be at 0000H. It will occupy 2 bytes. So the next instruction will be at 0002. So it will the program will occupy subsequent memory locations continuously. After L3 sjump L3, the next memory location you can write this part, the subroutine part, continuously. You need not bother about any other addresses, and the last sentence can be this label sentence DB, we are ready. So this label will be replaced by the exact address when the assembler converts this program into machine code. When the assembler converts the code to machine code, it will replace all labels with exact addresses and relative addresses. So we need not bother about address calculation. We need not calculate which is the address of this instruction, which is the address of this instruction, and so on. I hope you understood the program. As I say always, if you have any doubts, call me up. This program is to be used if you are asked to transmit a long sentence serially. If it is a small word, you need not go for this program. You can use the programs that you studied earlier. Thank you.